All right, thank you. So today I'm going to tell you how to take your cheap consumer drone and turn it into a mosquito killing machine. So step one, we're going to tie on our mosquito zapper. Step two, fly it around and kill mosquitoes. Any questions? I think we can do a little bit better than that. So if you've ever seen me talk at this meeting before, I like to talk about big drones. Our philosophy has always been bigger is better. Bigger props, bigger motors, more power to carry more pesticides. But big drones come with their own set of issues. One, they're kind of expensive, depending on who you are. They're expensive in New Jersey. They can be hard to transport and set up. They require a little bit of maintenance to keep them running in top condition. You need a fair amount of experience to fly them safely, and sometimes these are custom-built machines with limited support. The alternative are consumer UAS from DJI. Consumer UAS are cheap, they are reliable, they're very easy to fly, but they come with their own set of limitations. They're really good at taking photos and videos, but that's all they do. They're not really equipped to do anything else. There's no sort of output. They're not really equipped to do anything else. There's no sort of output that can allow you to attach any sort of mosquito control accessory. But the one thing that we can control are the lights. So underneath the arms of the Phantom are these navigation lights. You don't want the glare, especially in low light conditions, you don't want the glare from those lights affecting your images. So the one thing you can control is you can shut those off by pressing a button on the remote control. And we can use that to our advantage. So this is a circuit that I developed that allows you to control things with the light. So we have our Phantom up in the corner with the navigation lights, and right below that there's a sensor. And that sensor can tell if the lights are on or off. It sends a signal to the microcontroller in red, and what a microcontroller is, it's just a miniature computer with the instructions, and those instructions say, all right, if the lights are on, that's the default condition, the lights are normally on, turn the circuit off. If somebody turns the lights off, then turn the circuit on. The microcontroller then sends a signal to a circuit board, and that circuit board controls the accessory. In this case, it's a pump for sucking up mosquito larvae, but we can use the same basic circuit to control any number of different things. And we do have a patent pending on the design, so please don't steal it. So this is a 3D clear CAD image of the device. The first thing that we built was a tablet dropper. So it's based on Natural RT30 tablets. We can stack 15 of them up in this standard 50 milliliter. We have rechargeable lithium-ion battery, the microcontroller, and a motor which pushes the tablets out the bottom. We've got a set of clips here which allow us to simply snap it on to the landing gear of the Phantom, installs and uninstalls in less than a minute, and the light sensor up in the top left there. And here's the thing in real life. The whole entire body is 3D printed, snaps right onto the back of the Phantom, and we can control it through the lights. And just some of the stats, we've got about $75 of parts in this thing, weighs 216 grams, and with the Natural R tablets, we can treat, with 15 of them, we can treat about 1,500 square feet. And because of the weight, we're going to lose about 4 minutes off the total flight time of the Phantom. So now I'll show you an example of this in use. This is a closed treatment facility. It's not in use anymore. It's locked up. We don't have access. We don't have easy access to it. So we're outside in the parking lot performing a manual flight. So we're taking off from the parking lot here. We're going to fly out and over the fence, speed things up a bit. And now we get inside and we'll switch views. And this is what the pilot can see. This is a view from the Phantom. These are all the open troughs with stagnant water. And if you look down at the bottom middle of the screen, you'll see a tablet drop out. There it goes. Hopefully you can make that out on the screen. And to show you the accuracy and the stability of this platform, that's about a 15 by 20 opening. So we're just going to hover over that. And again, down there it goes, right down the middle. And we can continue on and treat this whole facility from outside without ever stepping foot inside. this entire facility. So not only do we have the ability to treat an area that is difficult to access, but more importantly, using the Phantom to treat this is much safer than doing a manual application. Imagine doing this by hand. These walkways are only about 2 feet wide. It's about a 15-foot drop to the bottom. I've done it, and it's definitely a hazard for your inspectors. Doing this with a UAS is much safer, much easier. So we can kill our mosquitoes with the Phantom. We want to see if we can collect some mosquitoes. So this is the larval collection unit that we developed. The light pink is a float made out of simple insulating foam. We have the same electronics as we had in the tablet dropper, just instead of running a motor to push the tablets out, this time we've got a pump to suck up mosquito larvae. So the pump sucks mosquitoes in through this funnel, up through this tube, into another 50 milliliter sample vial. The vial has screened overflow holes, so you can pump as much water as you want through it. The mosquitoes stay behind, the excess water drains off. And some specs on that. It's about $61 in parts, weighs 218 grams. So it's got the same weight almost as a tablet dropper. Because of the large surface area, we're blocking some of the thrust from the props, and so we're losing about 8 minutes of flight time with this device. And here it is in real life. It's not pretty, but it works. Everything in hot pink was 3D printed. And look closely here at the landing gear, you can see a set of clips. So this just clips right over the landing gear, installs and uninstalls in less than a minute. We look over here, underneath the arm here, there's our light sensor. So what we've done is we just popped out the original lens in the Phantom and popped in our light sensor. And then, of course, our electronics are here with a rechargeable battery, a microcontroller, and supplemental circuit. So now we'll see this one in action. We're outside this facility. This is we kind of staged this with Middlesex County because we did this in the winter. We had to kind of put them here, but we're outside the facility, flying in. And if you can hear the wind, this was a really windy day. I was concerned how this would perform in high winds, but it's about 12 to 15 mile an hour gusts, and the Phantom had no problem flying with this attached in that wind. So we're approaching, we're over the pond, and now we're just going to come down and land right on the surface of the water. Once we land, we can shut the motors down, kind of let the mosquitoes get used to it and resurface. If you look, you can see the mosquitoes at the bottom of the pond there. So we can see through the water, kind of see what's going on underneath. If we pan up, there's our collection vial. We're going to turn the pump on now, and you can see the excess water coming out through the overflow holes. Mosquitoes and anything else you suck up stays behind. Now we'll pan back down, and that's the funnel that you saw in the previous pictures. And I don't know if you can make it out on the screen, the resolution's not great, but you can see all the particulates and stuff. There goes a pupa getting sucked up. All the particulates are getting drawn in there. If you look closely, it gets sucked in through there. And we can run this, we got plenty of power. You can just shut down the motors and run this for as long as you need to. You can power the motors back up, there it goes, and kind of move yourself around the pond to different areas. And when you're done, we just power the motors up again and take off. And there's the mosquitoes in the vial. You can simply swap out the vials and put in a new one. You can see they survived through that new one. You can see they survived through that trip, survived the trip through the pump with no problem. Now this is just the first prototype. We literally just tested it out about 2 weeks ago. You saw how we lost about 8 minutes of flight time with that float design, probably because we're blocking a lot of thrust from the float design that I came up with. It's actually based on a commercial design, but I drew this sketch up on Thursday. This is the beauty of modern technology and 3D printers, and by Friday I had this printed out, assembled, and tested. So in the future, we're probably going to go with something like this that's blocking less of the thrust from the props. Should get that flight time back. You may have noticed a lot of glare on the surface of the water. We can add a polarization filter to the Phantom camera that should eliminate that glare and give us a little better view of what's going on underneath the water. The focal length is also off. You know, the Phantom is made to see out to infinity. It's underneath the Phantom. So we may raise it up a little bit, try and adjust that focal length to get a clearer image in the water. And right now, it really works best when you have high population densities. The pump that we're using isn't all that powerful, and so we may look at either adding additional pumps so that we can sample a larger area at once, or maybe putting one larger, more powerful pump to draw the mosquitoes in from a little farther distance. So what's next for us? I should point out, you saw that, you've heard this probably several times today, but the tablet unit, you can't apply pesticides from a UAS without a special authorization from the FAA, and so that's something you would need to plan for. But what else can we do with these small consumer UAS? Obviously, we're limited by weight. We can't carry that much, but we could certainly easily construct a granular unit, something that goes out at a very low rate. It might be good for, we could simply reverse the pump that you saw in the larval collector and squirt out concentrated liquid larvicides rather than sucking up mosquitoes. But really what we want to do is go even smaller. This unit here is the brand new DJI Mavic Air. It's barely larger than your cell phone. And what I'd really like to do is develop some units for this, because our ultimate goal is to get into urban environments, get into backyards, and be able to fly around safely and fly around and make applications safely and without freaking out the public. And I think if you paint this up, black and yellow stripes, kind of like a bumblebee, put some googly eyes on it, people might be excited to see it fly around their backyard, knowing mosquito control is coming. So we'll see. And if you want to stay up to date with what we're working on, social media, just search out mosquito drones. We haven't posted a lot recently because a lot of that patent stuff was in limbo, but now it's pending, so we can share a little more. Feel free to follow. Thank you.
Take one question.